Welcome to a presentation of Hystrix. My name is Sanjay Acharya. I'm a member of the architecture team. And this is the logo for Hystrix, basically a porcupine. And a porcupine really defends itself because of all its thorns, right? So this is my Twitter. Follow me, tweet about me, make me famous, make me rich. Follow my blog, let me get some Google AdWords going and make me rich again. So let's get going. So what are we trying to solve here? We're not trying to solve hysterics. Hysterics is when you go like crazy and so on. That might be something that we do at after party, where I can give you some tips. That's not what we're going to solve right now. We need some reflection. I did a presentation on Hystrix some time ago for the architecture team. At that point, our shopping site looks something like this, with its dependencies. And this is how I captured it by using sut.overstock.com. For those of you who don't know what sut is an application that describes the boundaries that an application has to other applications. More recently, as you can notice in our job, for this presentation. And this is how we look right now. On one side, it's a good thing because we've grown, right? So we've grown, we've broken things apart, we're making new features all the time. So one part is it's a really good thing. Now, in order to describe this further and to show you the value of Hystrix, I need to get into a fictional use case. I was going to use our shopping site, but then I didn't really know about is it going to be okay or not if people walk in, they're not my company. So I decided to use a fictional use case. And for a fictional use case, I have a website called Thorns and Things, based off this. Again, this is Thorns, not Thongs. Thorns is a different website altogether. As with any website where people come and shop, there is a reward service, right? Where people go and accumulate rewards and we get to display their rewards. Our rewards website for Thorns and Things is called on every page, okay? And Thorns and Things, the rewards web service does a lot of things apart from just giving you your custom rewards. It has some long-running operations and so on. So the developers of rewards web service, in their wisdom, decided that they need to set the read timeout to be the longest timeout of any resource on that web service. So the longest running resource was 5 seconds or 5 milliseconds. So that's what they set it as. And our Thorns and Things website uses the rewards web service client to make calls and then render the rewards. So, hey guys, there's some space out in front here, so if you want to come on over, this is great too. So, a happy shopping experience with Thorns and Things looks like this. We have customers who are buying stuff. The Thorns and Things web cluster is looking really super. The average response time is making calls with like 100 milliseconds to display the pages where the rewards are present. It uses certain other services as well during its call. Now everything is looking good, people are buying stuff. Suddenly they start seeing that the rewards web service starts going latent. You don't know what's exactly happening, but it's going latent. And your average response time has now creeped up. And as a result, these people who are shopping are seeing latent calls. The servers are getting a bit more hotter because a lot of requests are now stacking up on them. Fair enough? Time proceeds further. We get some more servers that are gone bad. It's now shut up to 3 seconds. A lot more calls are stacking up. This is getting pretty hot. Time passes and now we're pretty much hosed. Everything on the web has all stacked up and we're serving OTONs. Now, equivalent of ONOs, but OTONs. So what just happened? Well, basically this. This is exactly what happened. Merging in here, collided with Sam's fans to give you a good result. Technically though, what happened? On any good website, a website will have multiple dependencies. On a good day, everything is looking good, everything is green, things are moving fine. But in this scenario, what happened was we had one of these services that started going latent and thus leading to blocking all the container threads. And soon this just cascaded out of control and nothing could be serviced. Another scenario that we had recently in our test environment, and this is a factual scenario, the audit DB was down for maintenance. Mike out there is smiling because he's the one who contacted me with a very stern look. Audit DB went down. Service usage tracker nodes started failing their health checks because audit DB was down. And as a result, they got kicked out from the whip. Now, service usage tracker clients are running on multiple test web apps. or web services. And they were all trying to make calls to SUP, and SUP would reject it because it's downrated. But our service history client, in its wisdom, was retrying the calls every time around when you got a failure. Why? Because it said, like, if there's a failure, I can try again. There's no reason it can't. But in this scenario, the fact that it did retry caused the network to flood and graphs lit up, and I got some calls from some people. What would have been really nicer is if we could have detected, the SUP client could have detected that, hey, something is seriously wrong with the service history tracker web app. I'm making certain calls and they're failing. I want to trip the circuit and not make any further calls for a certain period of time, thus allowing service history tracker to recover. Or to be able to manually trip a circuit to prevent further calls to SUP. That would have been nice. It wasn't. This is where Hystrix comes in. So I'm going to let you guys read through what the definition of Hystrix is, but it was basically something that was evolved out of resiliency engineering at Netflix. There is a particular slide that I saw on Netflix where they said the entire Netflix went down because of a missed semicolon. And I really don't know what exactly that meant, but I guess that might have driven how the roots of Hystrix. Okay? So they went ahead and the resilience engineering team went ahead and created this library called Hystrix, which was adopted since 2012. And today, all their calls, pretty much all their edge calls and everything else, is wrapped with Hystrix. And as a result, they have found dramatic improvement in their uptime. So what's the purpose of Hystrix? One of the purposes of Hystrix is protection from and control over latent third-party application or our own internal application. When one of these go bad, we want to be able to have control over them. Another purpose is we want to stop cascading failure when something goes bad in a distributed system. So in our case, the rewards web service went bad, and we just had the rewards thorns and things at one client. You could have very easily had the customer app as a client. You could have had the rewards web service as a client, and so on. And when you have this, when one web service starts going latent and starts going bad, it can start cascading to all of these and results in them going down. And now you have a big system-wide, well, I don't want to use that word, but you guys know what I'm saying. So you end up with a bit of a problem. And then people need to go and restart it. So one of the recommendations is you want to be able to fail fast and recover rapidly in such kind of scenarios. Like in the case of SUP. You want to fail fast at that point and then recover when things start getting bad. Another part is we'd like to be able to fall back and gracefully degrade our system. We'd like to provide a meaningful fallback to the customer, saying, hey, you're not able to do something right now, but this is how, instead of causing everything to go bad. We want to enable real-time monitoring and operational control. One of the things I found last year at OSTOC when we were trying to diagnose certain issues, which was most valuable to me, was the monitoring that had been set up by our TechOps people and our NetEng people with Graphite. The monitoring was extremely valuable for us in order to see how things are behaving. And it continues to provide value. And Hystrix does the same thing. Some design principles that Hystrix is based on is to prevent container hogger threads. What that means is Tomcat container threads, we don't want that to be hogged on by any single dependency. Another principle that it tries to rely on is you want to be able to shed load fast instead of queuing it up. So if you are encountering a problem, a latency or something else, you want to be able to shed that load really fast rather than queuing up a bunch of requests that cannot be serviced. You'd rather fall back and give something meaningful really fast. Another, this is pretty much what I talked about in the previous slide, previous bullet point. We like to use circuit breakers and fall back to something meaningful and limit the problems to a single dependency and isolate it. Again, you want to optimize the time to discovery by using real-time monitoring and metrics. How does Hystrix accomplish these goals? It wraps all the dependent calls in what's known as a Hystrix command and runs that on a separate thread. By running on a separate thread, you're isolating. You can control the thread pool on it. You can interrupt threads that are running too long. It will time out calls that are running longer than a certain period of time, certain threshold that you've defined ahead of time. It maintains a small thread pool or a semaphore beyond which it starts rejecting calls that come in. It constantly measures success, failures, and thread rejections. It trips a circuit breaker either manually or automatically when things start going bad. It performs fallback logic when a request fails, is rejected, or in the case of a short circuit. So how does it work? Really, how does it do all this stuff? I'm going to show you a diagram. I don't know how much of it is going to be visible for the people in the back, but I'm going to try to do my best. So at the core of it, there's a Hystrix command or a Hystrix observable command. I'm not going to get into the observable version because I don't know how many of you guys attended my previous presentation with Joel on observables, but let's just go with the Hystrix command. So Hystrix command is executed. And when it's executed, the first thing it does is check to see if there is a result already in the cache, assuming that it's been set up to cache request. So if it is in the cache, you immediately return back that result, and you're good. Else, what it does is it checks, is the circuit breaker currently open? If the circuit breaker is open, then we're going to short circuit. We're not going to simply call the web service or any downstream resource because the circuit breaker is now open. And then it says, do we have a fallback defined for us that we can call, which is meaningful? And if the fallback is not defined, then we just throw an exception. Otherwise, we provide the fallback. In the scenario where it says the circuit breaker is not open, we go and check the thread pool, the semaphore thread pool, to make sure, hey, can I let this request go through in the number of threads? And if that is allowed, we then run through, execute the request, and return it back. If that fails, then again, you go to the fallback and do the fallback logic. So let's look at some code right now. We've been talking about theory a lot. Let's look at some code as to how Hystrix does this. So we have our archetypical hello world command at this point, and hello world command extends what's known as the Hystrix command. And this is an abstract class. And you need to extend that, and in your constructor, you need to provide something that tells which group you're in. So a command group is basically something that's used to group a set of commands together for reporting and alerting purposes. So you do that, and then you define the run method. This is where the heart of your work executes. And in our run method, all we're doing is we're returning back hello world. So this is a basic Hystrix command. How do you execute it? Well, you say new hello world command dot execute. At this time, this is a blocking call, and you get back to greeting. What this means is this new hello world command here is actually running on a separate thread. Okay, but you don't notice that. And you get back to result. There's another way you can do it, is you can queue it up, and you obtain back the future, so you don't need to block. But at some point downstream, you will have to ask the future to get back the result. And the third way which you can do it is using observables, which Joel and I talked about, but it's a way in which you can subscribe to a Hystrix observable with an observer that gets notified asynchronous. So in order to proceed with our examples, I have something here known as a get delivery estimate command. And the get delivery estimate command uses a delivery estimate web service client and an address and determines what's the delivery estimate for that particular address. It's pretty nice. You just provide it an address and it tells you really how long it will take to deliver something to that address. So if you see down here, the client calls delivery estimate client. And so configuring the delivery estimate command, so each command has a group that is associated with it. We also need to provide a name. So if you don't provide a name, it just uses a short class name as the name of the command. Alternatively, we could have provided a name for the command saying delivery estimate command or whatever. All commands of the same group tend to share the same thread pool in the very end. So that's an important thing you guys need to know. The run method that I talked about does this. It goes ahead and executes the actual task. And if any exception occurs from this run method, it starts counting towards failure metrics, saying something's going wrong, as in more of these start happening, right? So if our service started going latent, you will start seeing these happen, or if the service just started throwing exceptions, you'll start seeing this happen more. Now, we talked about a fallback. This is how we provide a fallback. So if the run method, for whatever reason, fails, it goes ahead and invokes the fallback. Our fallback is nothing more than just returning back a null object pattern which says, I can't compute the delivery estimate right now. Okay? And if you were using the Tons and Things web app, what you would see on your website would be it's not currently available. Your rewards, for example, are not currently available, or your delivery estimate couldn't currently be computed. That's all. Okay. The fallback method, it will get invoked on the failure of the run method. If the circuit has been set as open, it will also be invoked. So the circuit is open if a lot of failures occur within a certain time frame. Okay? That's when a circuit gets open. When requests cannot be submitted also because the thread pool is full, that's when the fallback could get called. So some fallback option that you can do is return back a simple value. You could return back something from a cache if it makes sense, and you have a cache. You can obtain that back from a different resource. So our TechOps people are now standing up a DR center down in North Carolina. So maybe if you started experiencing issues with the delivery estimate web service, we could create a new Hystrix command as part of the fallback to call out to North Carolina to get the delivery estimate for a period of time until our primary service starts coming back up. Okay? A fallback, so you could have a fallback that falls back to another fallback, but in the end of it, you need to make sure that your top level fallback always returns back something and doesn't throw exception. That's the recommendation. Now, in some scenarios, we encounter invalid exceptions, like validation exceptions. For example, if you have an address that's invalid, the web service client may throw an invalid address exception. This invalid address exception should in no means contribute towards metrics of failure, right? Because it's a valid thing. It's not something about the network being down, the web service being down, or any such thing. It's more a symptom of an invalid call that was made. So how do you handle this? Because if this throws invalid address exception in the run method, it's going to contribute to failure counts. So what you do in such a scenario is you need to wrap that with what's known as a Hystrix bad request exception. By throwing the Hystrix bad request exception, it will not add that to failure metrics. Resiliency patterns with Hystrix. Let's talk about certain resiliency patterns with Hystrix. One is the timeout. So we want to be able to time out calls that are taking longer than a predefined threshold. How do we do this? I create a new class called Hello World Latent command, which is designed to be latent. And what it does is, in the beginning of it, it sets up the isolation thread timeout milliseconds to be 500 milliseconds. But the actual run method is running for 1 second at the very best scenario, right? So it's 1 second of sleep time. So this command is always going to time out because you set your timeout to be a far lesser value than the run method is going to run. So it's always going to fail the run and call the fallback. So if you were to go ahead and create a simple test that tests this timeout, you create the command and you execute it. This is going to block for 500 milliseconds as defined, and then it's going to call the fallback. So if you run this, you will see that the fallback is removed. This is an example of timeout where you enforce a timeout. The circuit breaker. So we want the circuit breaker to trip when certain failures start occurring. So how do we do that? So we have here what's known as the Dr. Evil Hello World command. Anybody here Austin Powers fans? Okay, well, I guess I'm going to one. Oh, Lionel, I got Lionel out there. Awesome, Lionel. Oh, okay, a few more guys. No, Lionel put up his hand. All right. So the Dr. Evil command, it's just going to throw runtime exceptions saying that it wants sharks with laser beams on its forehead. That was one of the desires of Dr. Evil. And as a result, this is going to fail every time over. And when it fails, it's going to call the fallback. So if we go ahead and execute this in a loop for, let's say, 1,000 times or whatever, this is going to fail back every time and call the fallback. And if we then go ahead and obtain back the command key and see if the circuit breaker was open, we will notice that the circuit breaker was open. So this is an example of a circuit breaker, where it stops sending any requests after a period of time. Load shedding, isolation threshold, or bulkheading. This is another design pattern. I don't know, well, how many of you guys are from India, Pakistan, or that kind of area? You guys all should be knowing what I'm talking about as far as load shedding goes. We always lose power in one way or another through summer heat. So it's kind of nature. So what we do is we'd like to be able to isolate the number of threads, right? We'd like to say, hey, this particular dependency you get to run on only 10 threads. And this one you get to run on this. So we're trying to isolate or bulkhead them out. So if this one starts failing, it's going to time out and return back, and both of these are still healthy. So your Tomcat threads are not really getting stuck up. So to test our hello world latent command, what we do is I'm setting a pool size of 10. So I'm saying this command, whenever you execute it, can use only 10 threads. And during the run process, I'm sleeping again for a second, and we have the fallback down here. A unit test on that, what I'm doing is I'm saying I'm going to loop from 0 to the pool size, and I'm going to enqueue into that 10 requests. Each of them is going to wait for a second, right? So I'm exhausting the thread pool of 10 threads. And when I run this extra command down here, this command will get rejected because the thread pool was full, and it will result in calling the fallback command. But all the rest of them, they worked out just fine because they got themselves in time. Request caching. I don't know what other image to put into this, but we have requests and caching. If I offended anybody who's a big fan of the song, so, in the case of request caching, what you're trying to do is, if the same command is being executed in multiple parts of the thread, we don't want to necessarily go and fetch back the delivery estimate every time around. If you've already fetched that once in the thread, there's no reason you need to go back again and do it, right? If you have multiple threads that are making the same call again, you would rather just cache them. So in order to do that, you need to provide the Hystrix command, what's known as a cache key. And the cache key is a unique string that defines what that command is. In our particular case, we just use the address to string, with the assumption that each address is unique. So when we run this as a test, the first thing you need to do is you need to set up what's known as a Hystrix request context. This is very similar to our processing scope begin scope. Okay? Then I create an address. This is Empire State. And we go ahead and execute this command. And the first check we do to see is this from a cache? And clearly it's not, because it's the first time it's executing that command. But then we execute the same command with the same address, which is a cache key, and we notice that now we're getting it from the response cache. Right? Now, if you were to do this in a servlet container, we'd have a servlet filter that in the beginning does the request context creation, lets the filter chain run through, and at the very end it's going to call shutdown of the request context. Request collapsing. So this is not a design pattern that's used that much. I couldn't really get any good examples of that, but it's basically a way of saying, you know, if I have a lot of requests coming in, like say maybe around 300 requests to obtain back price, what I'd instead like to do is behind the scenes, I'd like to optimize it so I don't need to create 300 threads and 300 network connections. I'd rather just collapse them into one batch request with one thread and make a call downstream and obtain back the prices and then re-expand out the call. So the way this works is, this is the figure where I talked about it before. So we take multiple of these commands. This is a typical run flow where each of them executes and uses a single thread. But with request collapsing, what you do is you go ahead and you collapse the request into one single network call that responds. So why use request collapsing? Well, I'm going to let you guys read that through while I drink some water. Okay. So let's look at a request collapser command. So here we have a Hystrix collapser that we extend instead of the Hystrix command. And you see the first argument is the batch return type that we want to provide back. In our case, we're saying long and double because we're getting a product price back. And down here, this is the response type, which is the double, which is the price. And this is the request argument type, which is the long. We then go ahead and set up our command property, saying, hey, you know, I'm willing to wait up to 100 milliseconds for commands to arrive before I execute it. And at max, I'm going to have 5 as my batch size. Okay? Now, this is the part where we provide back a batch Hystrix command. So you go ahead and create a batch Hystrix command that returns back a map of long and double price. Once you do that, and you go ahead and this is where the responses come back, and you need to take the response and you need to set it back in this request object that's being passed in, which results in all the individual commands getting their value back. Now, request collapsing as a demo, this is what you would do. You would say, create my context. You need to create a context just like before. Then I'm storing the map of long in a future of double, which is basically the call for price. And I say product price collapse command, create a new command, and I say product price put product ID, and I enqueue the command out. So at this point, this is not a Hystrix command which is running in isolation. It's actually setting this command, and behind the scenes, Hystrix is waiting up for a period of time for other commands to arrive. One more thing I want to mention is in this example, you will notice that I set the batch size as 5. Okay? So after we do that, we just run through the prices and just display out the product and the price. So if I were to run this test, you will see that 2 batches of requests were made, for 1 to 5 and 6 to 10. And all of these then finally is the result. So adopting Hystrix. How do you go about adopting Hystrix at Overstock? We typically do an interface implementation style of development, right? So breaking code into interface and implementations, apart from the just nature of decoupling, has one benefit that allows you to create proxies, it allows you to use patterns such as adapter and so on. And we're going to do something similar. So we have delivery estimate client interface that gives you back a delivery estimate. And down here, this is our Jersey client, typical Jersey clients that we guys develop with. And what the Jersey client does is, it says, client.target, base service URL, obtain back the delivery estimate. Now, this is how our Jersey clients are. So we use the decorator pattern such that we create something called the Hystrix delivery estimate client, which then delegates to the delivery estimate client info to perform its operation. And it does so like this. We have the delivery estimate client within it. Then what we do is we say new delivery estimate command or execute, and this is the command itself that uses the delegate. So we're able to reuse it. From the perspective of the API consumer who is working with delivery estimate client, if you are on a Spring module, this is typically what we recommend. We have a delivery estimate client being returned back. So first we create the Jersey client. We then send that in to the Hystrix estimate client and return it back. Now when we talk about how do we configure our Hystrix command and the properties. Hystrix uses what's known as RKS. RKS is basically a chameleon, a rare species of chameleon. And the reason it's called RKS is because it manages properties and changing of properties. It's very similar to our Overstock config. And it extends the Apache Commons library. And it's used by Netflix across the board. And you can read more about it here. So Hystrix uses that as well. So in the case of Hystrix, when you set up properties, there are different levels of precedence that it honors. One is the global default from code, and it means nothing when I show it right here. The other one is the global default value, and then the other two. I'd rather explain that as I move through. So in this class called Hystrix command properties, all the default command properties are set up. So if you're not provided anything for your Hystrix command, these are the values that are going to get used. So this is what you're going to fall back to when you just create a vanilla Hystrix command. You could go ahead and create a property file where you are overriding each of the default properties, in which case this is what's going to get used. If you were to define them in code, like this and so on, for Hystrix properties, core, pool size, and so on, this gets used. If you were to go ahead and create a property entry rather than using default with the name of your command, then this is what gets used. So there's a 4 level of precedence on how you handle this. Now, we're kind of unique, right? We don't use RKS, we don't use property files and so on. We're kind of unique. We have something called OSTK config, which is pretty damn awesome. So, how do we do that with Overstock config? Well, architecture team to the rescue. We try to do something. We would like to define properties such as this, right? In Overstock config, so that you can use config console to change those properties, view those properties, and so on. RKS luckily provides for us a bridge, a way to bridge our properties to RKS. So if something changes in Overstock config, we'd like to be able to bridge that into RKS, and Netflix will then just pick it up and make that change. There are certain properties in Netflix RKS that you can't change, like thread pool size. But there are certain properties like timeout and so on that you can change. Okay? So how do you enable this bridge? The simple annotation which we provided called enable Overstock config RKS bridge enables RKS bridge. So RKS you can use without Hystrix as well. It's totally independent. If you're using something else from Netflix, RKS bridge and Overstock config will not be. We also went ahead and put all these config properties into a single jar called Hystrix config, because you don't want to have this repeated in multiple jars and thus have conflicts, OSTK config conflict. We also provide some processing scope enablement What that means is Hystrix commands are running on separate threads. And because they're running on separate threads, they need to inherit the processing scope from the main Tomcat. So there is some functionality that enables that. Okay, metrics and monitoring. Hystrix provides some ways of doing metrics and monitoring. This is one of the core features. Randy Shoup, an architect from eBay and Google, said this very important thing, that you can have too much of alerting, but you can't have too much monitoring, right? Alerts, you get too many alerts, you shove them into your trash can, inbox, and so on, and move forward, right? But with monitoring, you go there, you try to get your data. It's not being pushed at you. It's a very wise statement, which I felt. So how do you enable monitoring in your web apps? Well, you need to create the servlet, you need to define the servlet, and make it available in some URL, okay? Hystrix has something called the Hystrix dashboard. This allows one to monitor all the metrics that are occurring within a web app in real time. When Netflix started to use the dashboard, they found that their operations, they improved the time to discover and recover from problems once they started using the dashboard. Now, this is how a command looks like in the dashboard when everything is healthy. You have the circle here that's denoting green, that everything is looking good. It has some other interesting things like the circuit is closed. Closed means everything is healthy. It will talk about your percentile times, saying at the 99th percentile, this is 61 milliseconds of time. And it will also tell you how many errors have been occurring somewhere down here. Like, I don't remember exactly where, but it tells you an error percentage down here. Now, this is what the dashboard would look at for all the commands when you use multiple commands. I just took this from Netflix, and it contains different commands and how each of them are looking. The interesting thing with this is, the minute you look at it, you know that something is looking good or not, because it's very visual. When a circuit has been opened because there's a problem, this is kind of what you will see, where it's kind of red, and it shows you the error, and it shows you that the circuit has been opened. So now, I'm going to try to do a demo, if it works. Okay? Again, the demo gods need to be kind. So for the demo, this is a setup that I have. I have my Constantine's website, which uses the delivery estimate client to make a call to the delivery estimate web service. Delivery estimate client itself is Hystrix enabled, so it's quite resilient. And this is the Hystrix dashboard that's talking to the metrics that are being generated by cons and things to display its graphs. So I'm going to briefly exit out of the presentation. So if I go down here, this is my web. I think if you can see this, I'm going to go ahead and make a call to get the delivery estimate. And if you see down here, it successfully worked. So this is a good scenario. And I'm also going to go ahead and see the Hystrix monitor here, and it's calling this web app. This is what it looks like. Everything is good. I'm going to take some time, and I'm going to start a JMeter script that's going to hammer our website for the delivery estimate command. So I started the thread, and you see it showing you everything is good, right? Things are looking good. Now what I'm going to do is I'm going to go to Swagger, and I'm going to simulate some latency in the delivery estimate command. I'm going to set up, like, say, 5 seconds of latency, and I'm saying try it out. If I come back to my Hystrix monitor, oopsie, there you go. You're going back. But if you come back to your web app, and you say get delivery estimate, it fails fast. It's not really blocking anymore, right? It doesn't block. And then I go back to Swagger, and I set back my time to be 0. Say try it out. And you will see if you come back to your Hystrix monitor, things start becoming better again. All good, huh? And if you go back to cons and things and say get delivery estimate, we're back. Alternatively, if I go to my command line, and let's see, the delivery estimate web service is doing a ton of stuff, I'm going to kill it. And I come back to Hystrix monitor, you start going back, right? I go back in, but the web app is still functional, and it's not really dying on the threads or anything. It's doing perfect. Come back to my console and restart my service. Come back to Hystrix monitor, and we wait for the web service to come back up. In the meanwhile, it's short-circuiting it. Notice that the circuit is open here. That means we're not really issuing any calls to the web service right now. It issues a single call after some time and says, okay, you're looking healthy right now. Now everything is back up and functional. So, now that we've done that, hey, this is it. It's all about keeping the lights on, guys, at our coursetalk.com. So, I'd like to open up for any questions, if anybody has any. Otherwise, thank you guys, you've been a great audience.